One of the ISS's greatest engineering triumphs, it's been generating its own power for over 177,000 hours and counting. That enables round-the-clock air conditioning, fundamental to astronaut survival.
This cannot go down. It's not like a power cut in our homes where, you know, we can get a torch or light a candle or something. If this goes down, astronauts will die.
When the ISS enters the shadow behind the Earth, the temperature can drop to below anything ever experienced on our planet. Without the protective cocoon of the space station, the ferocious cold would kill astronauts in a matter of moments. Conversely, when in sunlight, the temperature can soar.
Temperature and managing temperature on the ISS is very important. If you imagine the extreme temperatures that you can get on the ISS if you're facing the sun or not, could be plus 250 degrees or minus 250 degrees.
So you have these huge temperature extremes simply because of being sunlit or being in the shade. And it's something that you have to keep in mind when you're doing your engineering.
Of these threats, overheating is the hardest to manage.
With lots of people and electronics inside a spacecraft, you tend to generate more heat than you know what to do with. And so the problem in general, at least in Earth orbit, is that you've got to get rid of heat.
If heat built up uncontrollably inside the ISS, it would become a deadly incinerator. So cooling the station is a crucial priority.
Standard ways of cooling that we're used to on Earth don't work. Convection does not work. Conduction does not work.
Conventional aircon would be ineffective. Scientists had to come up with a cooling system for radiating heat away from the ISS. It needs to be liquid-based, but there's a dilemma.
Ideally, what you'd like to be able to do is just put it through a water cooling system and then get rid of that excess heat. If they tried to get rid of that excess heat using water, the water would just freeze as soon as it went outside into space.
Water is not the solution. Curiously, gallons of a deadly poison is. Hidden inside the hull, there's an intricate network of pipes picking up the heat. But they do carry water. The secret is, the water goes through heat exchangers, where ammonia-carrying pipes take the heat outside the ISS. Huge radiators finally dissipate it into space. Ammonia is used because, unlike water, it doesn't freeze until minus 107 degrees Fahrenheit. It remains liquid and flows through the radiators, even when the ISS is behind the Earth.
Ammonia is used as a heat rejection system because it is one of the best thermodynamic fluids to use as a heat rejection fluid. Unfortunately, it's incredibly toxic and kills human beings on contact.
In May 2013, for reasons unknown, ammonia is spotted leaking out of one of the cooling pipes. There is no alternative but for astronauts to climb outside the ISS to fix it.
Fireflies coming off our space station.
The International Space Station has a network of vital cooling pipes that are filled with ammonia, a substance so toxic it can kill.
Now, there was a time in 2013 when Chris Hadfield and his crew spotted a leak from the ammonia pipes, and they had to react very, very quickly to stop that leak.
The leak appears near one of the solar panels. There's only one viable response to this critical emergency. Astronauts Chris Cassidy and Tom Marshburn must exit the ISS and investigate.
Sunlight, I am putting my visor down.
They discover ammonia spewing out of what they think is a pump.
Fireflies coming off our space station.
If they can't stop the flow, they might have to evacuate the space station.
You're going to monitor for an ammonia leak. If some reason a flowing leak is observed, immediately stop turning.
The pair attempt to replace the suspect pump. Hard work in cumbersome spacesuits. And they must avoid contact with the potential lethal ammonia.
Be careful not to put your hand inside that window, and also the seals on the FQDC are no touch.
No touch on the seals. Don't penetrate the window. Copy all.
5.5 grueling hours later, the astronauts return to the ISS unharmed.
That's affirmative. The ammonia valve is closed.
It was fortunate that the leak wasn't water, because along with oxygen, water is one of the precious commodities people cannot live without. It's so precious, in fact, that inventing equipment to recycle it was one of the space station engineers' highest priorities.
It's so important that we recycle as much of the water on the ISS as possible. And that includes things just like the water in the air.
The end goal is for the spacecraft to recycle 100% of their onboard water. That's far from straightforward, because much of it starts off inside the astronauts.
That water vapor comes from the individuals as you breathe, you exercise, you sweat, and then it comes off of the surface. So that's the water vapor that gets out into the air, and we're constantly ventilating the air through the module.
Water vapor from the air is collected in a condenser. Every droplet is valuable. Nothing is wasted. Even urine is recycled.
Let's say you're up here on ISS and you need to go to the restroom. You want to come to this cabin, and the first thing you want to do is grab this piece of equipment and turn this rotary switch 90 degrees to the open position. What that does is it turns on a fan, which creates a suction effect in this hose, so that you can use this yellow element for your number one.
After an astronaut uses the unusual facility, water products flow to the life support rack, where filters get to work. The start of a sophisticated process.
So the way space station turns urine into water is that the urine goes into what we call the urine processing assembly.
There are a number of stages. The first is treating the urine to prevent buildup of bacteria or other dangerous microbes.
That urine that we collect from the crew, we have to add chemicals to it in order to process it. Raw urine in and of itself would be a problem, because over time it becomes rancid, and that's definitely a bad situation on the space station. So that's why this is a dark fluid instead of what you would normally think of as urine.
Clearly, that is not drinkable. It needs to be distilled, where pure water is boiled off to leave the toxic waste products behind.
And then it goes through another cleaning process. There's lots of filters. And then some of the water is made available for drinking. And that's why we have the expression that the water recycling system is coffee to coffee. You can think about that.
The water that gets to the crew now is effectively cleaner than any water that we drink here on Earth. Even that nice bottled water that everybody likes so much, it's cleaner than that. So this is the end point in the process.
It tastes really good.
In water recycling, we are really trying to get to the point where we can recycle up to 90 or 95% of the water on the space station, which is really vital not only for going someplace like Mars, but also has consequences here on Earth.
Recreating the conditions that support life on Earth is one of the pillars of the ISS. But much of its equipment is still operated by Mission Control in Houston. The ISS will have to break free from that if we're ever going to conquer deep space.
We're going to have you go to the ticker shroud removal.
Okay, copy.
The International Space Station provides its own life support, but it's partly controlled from Earth.
Go off a bit. Off a bit. There it is. Yep, I felt it. Okay, Swanee, what do you want for
Our flight controllers on the ground can control the robot arm and move that from the ground.
That requires constant radio communication. A major challenge because radio waves can't penetrate the Earth, and the ISS is often behind it.
What a beautiful piece of hardware.
We can have significant loss of signal with the space station. We're talking on the order of maybe 12 to maybe 40 minutes, maybe a little bit longer.
In the early Apollo space missions, they tried to fix the problem with a fleet of jets that bounced radio signals between each other, ground bases, and space capsules. But it was expensive and unreliable. The ISS uses a more sophisticated system.
There are various assets that we're able to use to communicate with the International Space Station. So one are via satellite.
A network of high-orbit satellites relay radio data between the ISS and ground bases in several countries across the globe.
And mission control, we're looking at various video feeds. So we have the first board over here, we call it the 6-pack. And the International Space Station allows, at a minimum, 6 downlink video channels. And then we can be following the crew, what they're doing during their day.
Station Houston on Space to Ground 2, you have a go for Step 6, ingressing Dragon.
Copy that.
The live links are so reliable and fast, there is now less than a second's delay when astronauts communicate with Earth.
Hi, Dad. Hi, Dad. How are you?
Hey, Rob. Hey, bud. How's it going?
Currently looking at what we call the world map, it would show that the International Space Station is currently about to start swinging north of Antarctica. Another cool feature about the world map that we keep in front of the control room is the fact when other missions go on launch, we'll also see those vehicles where they are relative to the International Space Station.
3, 2, 1. Engine ignition, liftoff of the Falcon 9 rocket.
The ISS may still be in our local space neighborhood with the luxury of near-instant communications. But it's also our first stepping stone to reaching other planets and beyond.
Science for today and for deep space exploration tomorrow.
Inside this rocket is an experimental new module known as BEAM.
The first human-rated expandable structure to be flown in space, now attached to the International Space Station.
After docking with the ISS, astronauts test its unique feature. It blows up like a balloon.
It's an inflatable module that's attached to the space station. It's kind of unique in that the fact it is inflatable.
It looks great. It looks pristine.
Pressurized air pumped into the extraordinary new module transforms it into a rigid structure.
One of the unique things about BEAM is that because it is collapsible, you don't need as large of a launch vehicle to